And welcome to my second video on resolving forces on inclined planes. Now, in my last video, we looked at a block of mass m kilograms placed on an inclined plane at an angle of alpha from the horizontal. What we're going to look at in this session is a very similar situation. So we still have a block of m kilograms on an inclined plane, alpha at an angle of alpha degrees from the horizontal. But we also now have a force that is acting parallel to the horizontal, acting on our block. So as with last time, the first thing we're going to do is draw a free body diagram. So I'm going to put in a little dashed line to represent our plane. Putting our points to represent our particle. And then we just put our forces in. Well, just like last time, we're going to have mg acting directly down, as weight wants to do. We're going to have a normal reaction force acting normally to the plane. But now we also have this force F newtons acting horizontally. So that's going to come in here. Now, as before, our forces are not perpendicular to each other. And in order to be able to easily do calculations to work out motion parallel to the plane, we need to work out forces such that they are perpendicular to each other. So just like last time, we're going to go through and work out the components of each of the forces parallel and perpendicular to the inclined plane. So to start with, we're going to have a normal reaction force. That's already perpendicular to the plane, nothing to do there. We've got our weight. In our last session we saw that breaks down into mg cos alpha and mg sine alpha. However, we also now have this force F. It's acting into the plane, but it's also acting to push it up the plane. So we're going to have, in addition to that, a force acting up the plane, and we have another force acting into the plane, and we need to go through and calculate what they are. So just like before, we're going to look at that force F in isolation from the other forces, so we don't confuse ourselves. So we'll clone that, bring it down. Here are the forces we're not interested in. And have a look at our force F. So, again, F is the magnitude of our force. So that's going to form the hypotenuse of our triangle. We know it's going to consist of a force that's acting parallel to the surface. So I'm going to put in blue. And there's also going to be a force acting perpendicular to the surface, pushing it into the surface. So I'm going to put it in red this time. So just like before, we've got ourselves a right angle triangle. We've got the hypotenuse. So all we need now is an angle, and we can work out what the force parallel and perpendicular to the surface is. Well, from GCSE we can see we have two corresponding angles here. So the angle here must be alpha. Therefore, we know that sine of an angle, in this case sine alpha, will be the length of the opposite divided by the hypotenuse. So if we go sine alpha equals, well, the opposite force to the angle is the perpendicular force. So let's go perp this time. It's the perp force divided by F. So a perpendicular force is going to be F sine alpha. We also know that cosine of the angle is going to be equal to the magnitude of the adjacent force. In this case, the force adjacent to the angle is going to be the force parallel to the surface. So that's going to be parallel force or paraforce divided by the hypotenuse, in this case F. So in fact we can see that a paraforce, a parallel force, is going to be F cos alpha. So we've done that, we can put those two forces onto our free body diagram. So we're going to have parallel, we're going to have F cos alpha, and perpendicular, we're going to have F sine alpha. Now, to this point, the students new to this sometimes get a little bit confused because we've got both coses and sines of alpha acting perpendicular to the surface, and we've both got coses and sines of alpha acting parallel to the surface. That's okay. What is interesting here is that since the normal reaction force and mg cos alpha plus f sine alpha are acting opposite to each other, and it's an equilibrium perpendicular to it, the normal reaction force is no longer just going to be mg cos alpha. It's going to be greater than that. It's going to be mg cos alpha plus f sine alpha. When we come to do questions later involving Newton's third law of motion, that will become significant, as it will with friction. In my next video, I'm going to look at what happens if we apply a force to the block that is at an angle both to the horizontal and vertical and to the plane. Hope you liked the video. Feel free to comment on it. If you liked it, please subscribe.